Bismillahirrahmanirrahim. Assalamu alaikum. Before starting our lesson, there is a question for you people. Who is the best bowler in 2019 World Cup? Mitchell Stark, Muhammad Amar, Ferguson, or Archer? You have to answer this question till the end. Now let's start our topic. The name of topic is wave motion. Let's check the definition. A wave is a disturbance in the medium which causes particles of the medium to undergo vibratory motion. Uh, the word vibratory motion is important here. Due to this disturbance, particles of medium starts vibratory motion about their main position in equal intervals of time. It means there will be time period of the wave. You can check the figure. Waves produced in a rope. It is fixed from one end with a support. You can see particle P in first position. Wave is moving onward, whereas the position of P is not changing. You can check this, and this, whereas crust is moving forward. Crust and turf are two terms we will discuss next. Basically, there are two types of waves: mechanical waves and electromagnetic waves. The waves which requires any medium for their propagation are known as mechanical waves. Waves which requires any medium for their propagation are known as mechanical waves. And let's see examples. Sound waves, water waves, string waves in string, and spring are the examples of mechanical waves. Now we will check electromagnetic waves. Waves which do not require any medium for their propagation. These waves do not require any medium for their propagation. Let's check the examples. Radio waves, X-ray waves, light waves, and television waves are the examples of electromagnetic waves. The basic difference between mechanical waves and electromagnetic waves is the medium. Mechanical waves requires medium, whereas electromagnetic waves does not require any medium. We have also seen the examples, these and these. Let's discuss the types of mechanical waves. And the first type is longitudinal wave. In longitudinal waves, the particles of the mediums move back and forth along the direction of propagation of waves. Back and forth along the direction of propagation. Let's check the figure. A spring is fixed from one end and other hand is free for motion. Movement of hand is in this direction. Direction of the wave travel is arrowhead. Displacement of particle is in this direction. We can check that loops are compressed here and here, whereas spaced apart on this position. Let's check what is compression and rarefaction. Compression. Loop of spring are closed. It means the position where loops of spring are closed are known as compression. Repeat. The positions where loops of springs are closed are known as compression. Rarefaction. This term. Loops are spaced apart. It means rarefaction are the parts of the wave where loops are spaced apart. On this position means compression. Particles of medium are closer together. Loops of spring are closed, so particles of medium are also close together. Loops are spaced apart, therefore particles of medium are spaced apart also. We have discussed the example of spring. Hopes you have well understood. Direction, back and forth in longitudinal wave. It's an important point of this. Now let's check the transverse waves. In transverse waves, vibratory motion of particles of the medium is perpendicular to the direction of propagation of waves. Means if the particles are going in this direction, wave motion will be like this. Vibratory motion of the particle of the medium is perpendicular, makes 90 degree angle to the direction of propagation of waves. Examples of transverse waves are water and light waves. Let's check this example. We can check in this example that a wire is attached from one end to a support. It is fixed. Movement of hand from side to side is on this direction, and wave produced in this is like this. If we check, particles of wave are moving up and down, means moving about their main position. The upper parts of the wave are known as crust, whereas the lower parts of the wave are known as trough. We have marked this part is known as crust and this part is known as trough. Wave motion is in this direction and particle motion is in this direction. Check wave motion, particle motion. The distance from one crust to other crust is known as wavelength, or from one trough to the other consecutive trough is known as wavelength. Now we will move toward our starting question, which was, who is the best bowler in the World Cup 2019? The answer of question is Mitchell Starc was the best bowler in 2019 World Cup with 27 wickets, whereas Muhammad Amir, Pakistani bowler, was on number 7 position with 17 wickets in 8 matches, and Mitchell Starc has gained these wickets in 10 matches. On number 2 was Ferguson, and Archer was on number 3. Thank you for watching. If you like our video, then subscribe and click the bell icon. Thank you very much.